One thing I've been asked in person several times is how do I go from idea to prototype? And as someone who has built over 10 different projects this year alone, which I don't feel like they are good enough for the videos on this channel, I can confidently say I'm an engineer with two superpowers. One is the inability to focus for more than 10 minutes on a task before switching tabs and running Marble Rivals while Fusion 360 is open, as my laptop suffers due to my negligence. And my second power is the ability to lock in for 12 hours straight, just working on whatever project I'm laser focused on. As a low budget engineer I am, here is my personal guide for going from idea to prototype, which is similar but different from going from prototype to final product, but I'm still working on that. New product soon, hopefully. Here are the steps I would use to go from idea to prototype while avoiding wasting time and cost as much as possible. Identify what the idea is and have a fleshed out thought of what you want to do. You need to know in totality what the final prototype is meant to do, and that it can be easily achieved by itemizing the features you want the device or prototype to have. In order to exemplify this process, I'm going to use a recent project I had done, which allows me to perfectly explain and show the method's effectiveness. So if you like it, you can use it, and I'll also reference this in my future videos. We've established that you need to identify the features and functionalities of a prototype. Now, I had a task which was to build a biometric based attendance device. By the name, you can clearly understand the most important feature is for you to be able to take attendance of the students via biometric. But that's such a broad statement, right? So let's break it down and streamline it. For a project like this, here are some questions you need to answer in order to know what the possible features of a prototype are. What biometric sensing technology does it use? How does it store and identify users? Does it send the attendance data to some internet storage or database? Does it store any other information? Is it a portable or stationary device? Is it powered by AC mains or from a battery? If it's battery powered, what's the battery type? What's the expected runtime and recharging method? Would it have a Type B or Type C port for the charging port? How does the user interact with the device and give input? Does it have a feedback display of just some simple LEDs when you verify someone? Or does it have an actual OLED display? You can see how some questions are direct while others are dependent on the selection of a particular feature. Once these questions are answered, you should be able to list all the features. Here are the answers to the previous questions for the prototype. It uses fingerprint for biometric identification. It stores the time and unique ID associated with the fingerprint when attendance is successfully taken, and it stores that on a database in real time. The database requested that I would use with the Firebase database. It doesn't store any other information. It is battery powered and portable. It's rechargeable using LiPo batteries and also via Type-C ports. Then there will be a keypad and small OLED screen for the user to interact with the device. With these questions answered, we now have boundaries that define the scope of the project, and doing this is extremely important. Everyone from beginners to professionals need boundaries and a scope for the work that they do, because a project that is boundless means that the time needed to complete it is also boundless, and therefore it would never be completed. It will also have a boundless requirement of resources too. You need an end goal. Self-insert here. If you love electronics and robotics content, why not subscribe for more? I've been cooking some big projects, not as big as your mama, and I'm planning on taking an idea and concept I have from start to completion, with the aim of having a final product that you guys in my community can purchase or have as an open source project with a technical breakdown if my lazy ass ever does that. So if you want more content, subscribe, leave a like, and turn on post notifications for more. And also drop a comment to help others with some lessons that you have learned in your journey and experience with electronics and robotics. Now back to the video. The second step after outlining these features is to identify the ones that will make it to the final build, and to check if a feature is actually compatible with the components and resources available to you. How do you achieve this, both as a beginner, amateur, or professional? And the answer is research. You achieve this by doing ample amounts of research to the extent that it seems indistinguishable from you already knowing how to build a device. For the biometric attendance system, which is an embedded system, therefore the main focus would be on electrical design, I did research by finding what fingerprint sensor I had available, what fingerprint sensors were available for my budget I had, how to use the fingerprint sensor. Then I found libraries including tutorials on how it's connected and how it functions. By doing this, I was able to determine what the electrical requirements, size, and all necessary considerations I would need to use the fingerprint sensor was. This was done for all the other components I had selected. One thing you need to know is that some components are dependent on others, and selecting one core component might mean you needing more or less components to achieve what you want. For example, it was decided that the device would send data to an online database. Now, what data would it send would be date, time, and the unique ID of the individual whose attendance was taken, meaning the device needs to have the ability to connect to the internet and needs to be able to get the time accurately too. Because of that, I needed a microcontroller that can connect to the internet via Wi-Fi. It also needed to be able to handle all these components together, which meant the fingerprint sensor, which uses serial communication, a 4x3 keypad, an I2C OLED screen, and more. Knowing the following criteria, the microcontroller had to have 1. Wi-Fi module on board for comfort, 2. A lot of GPIO pins, 3. ADC, which stands for analog to digital pins, that's digital converter pins rather, serial pins, and speed. Now, my best bet for the price locally in this case would be an ESP32 Dev module. A Raspberry Pi Pico or Arduino Uno R4 with Wi-Fi were contenders too, but the ESP32 fits just much better than the Uno R4. To put this into perspective, now that I've selected the ESP32 as my microcontroller, all the inputs need to be 3.3V logic compatible, or I'll need a bidirectional logic level converter in order to convert any 5V logic to 3.3V logic, as the ESP32 pins are only 3.3V logic compatible. Now, of course, if you haven't been building for long, it's going to be hard to say when you connect everything after buying the components and using your resources that it's going to work without having actually tried it yourself. But I assure you, doing proper research and looking at other people's builds that are either what you are doing or mirror it in one way or another would allow you to know the feasibility of success on the project using the specific components you selected. Not to say that you can not do things that have not been done before, but you want to build upon things that people have already done in order to increase your chances of success with less resources being used or wasted. The thing is, as you build more projects, you learn how to design your circuits and systems better. You will also gain experience, allowing you to identify what works and what doesn't work, which therefore helps you reduce the amount of resources and time that you would waste during the building process. At this step, I focus on using the top to bottom approach and to create a flowchart or an algorithm showing how the device will function, with all its core features at the top down to all its sub features at the bottom. Now, why should you do this? Because it would help you in making technical designs and in programming your system. In fact, you should have done this immediately after deciding the features, because the features determine how it operates, and how it operates determine how the code paired with the electronics would run. Pretty much even the electrical and mechanical design are dependent on how it works. Now we've gotten our features, we've gotten our components, we know the algorithm of how it would function. Next, designing how the components will come together based on the previous research is what you're going to do. In this case, which is an embedded system project, you have to make or get a design which will act as your guide. This design should include all the components and how they interact with each other, their connections, and any limitations that you should be aware of during your building, or in specifications, based on whether it's you that build the design or someone else. Step 4. Now, with the design of components needed obtained, what I do next is to go from building instead of top to bottom, but from bottom to top. Well, let me rephrase. When building, instead of going top to bottom, you should go bottom to top, meaning from the most minuscule, smallest task to be done, and then building upward. But let's talk about that more. I'm going to address this for the electronics and embedded system specifically, because that's what this project that I'm using as an example was done based on. What that means is I start from the most basic electrical connection on a breadboard and keep on building upwards. In this case, I start out with the fingerprint sensor, write the code to allow me to use it to register, store, and access student IDs. I get the time and when the ID of the attendance was taken essentially. Then I connect it to the database and then make sure that all of the core functions are working. Each time I make progress on the code, I save the previous code that I worked on separately before making any changes and updating it. Now, this allows me to backtrack in the process of building in case I reach a point where I can't make anything work, things are broken, and I need to go back to a save point. So it's more or less like a save point. After ensuring that one component works, I add another component following the design I made, and I make any changes if necessary. And in the process of doing that, I update any design changes too. I keep on stacking more and more components, assuring that I make sure I get all that I need to working first before changing anything and adding more features. To put it into perspective, after getting the fingerprint working, I add the keypad and check that I can get it working on its own before adding it to the already existing working connection and updating the code by combining them. Then I also add the screen and ensure that I can get it working on its own before adding it to the already working connections and updating the code by combining them, and so on and so forth. Then I add all three together, combining them and creating a menu that works with the keypad that allows me to use the fingerprint sensor, which already works with the database and student ID. After all the core electronic is done, I shift to power and battery supply by connecting the batteries, then adding the charging controller circuit, which usually in this case will be a TP456 or any other variant of that works. Then I get the appropriate voltage to the microcontroller and any component by using either a buck or boost converter, voltage regulator, etc, because there's a bunch of options you can use. With all the electronics and programming done, what I do next is focusing on finishing and presentation. Since the prototype works, what I do next is I go from a solderless breadboard to an actual vero board, and to do that I solder all the components in with all the wires and any extensions that they may need. I use headers to give components repairability and replaceability, if that's a word. I also give adequate spacing over the years. I've just formed my own style of hand making my circuit boards with my own soldering pattern, which I try to improve every time. You can also design a PCB using the software of your choice and get it printed out. And a tip for a future project is we are going to be working with a sponsor. I will mention who for future projects on PCBs, but stay tuned if you want to see more of that and see me work on circuit designs, probably using KeyCard, but we'll go over that when the time comes for that. Now, this can either come before step 5, but it all depends on the boundaries and restrictions of your project or prototype. In cases where size isn't a critical factor, you can usually design your electronics, make your prototype, and then design a casing around it to fit it like I did here, which I did a 3D model of the case to fit all the parts, then assembled it. Although this was one of the first 3D printing cases I ever made, so it had quite some flaws as I was learning about layer lines, part strength, and a bunch of other things. But on the other hand, the smaller the form factor or the size of the final product, the smaller and more compact your design should be, which makes PCBs and the use of SMD components way more favorable than THT and larger components, which are all based on your requirements. And just like that, you should have gotten from your idea to your final prototype, like with the biometric attendance device I just talked about, which will allow you to make your very own creations from scratch. Of course, there are road bumps and challenges as you build, and it's not that it's always easy. I also didn't talk about a bunch of things, a bunch of techniques and parts that I use, lessons I've learned over the years. But if you like this kind of content and you want to see me go over techniques and things I've learned during the building process, let me know. Make a comment down below, like this video. If we get really good views, then I'll do another version of this that allows me to explain further about different types of things that I've experienced in the building process. Thanks for watching, stay safe, and may the electrical and mechanical forces be with you. If you want more content, subscribe, leave a like, and drop a comment of what step is your favorite to do and which you hated the most. Feel free to leave advice for others too in the comment sections, and with that, till next time. Feel free to watch any of the other videos on your screen from my channel, or you can go back to my much older videos and see how far I've come from different types of projects, and you can do it too.